So, good morning, guys.
Good morning, sir.
Good morning, sir.
Am I speaking
Good
visible?
morning, sir.
Yes, sir.
Yes, sir.
So, today we have to see the data exploration and visualization. Okay, up to here, types of data in machine learning we completed. So, today we have to see the data exploration and visualization. So, can we start? Any doubt in yesterday's class,
No,
guys?
sir.
Okay. So, the first one we have to see the data exploration. So what is data exploration? Data exploration, data exploration and visualization. Okay. So the first we have to see the data exploration. So summarize and analyze the data set to discover insight, patterns and potential issue before applying machine learning models. Okay. So which data we are collecting till now? Yesterday we collected data, guys. How to collect data? You all know how to collect data, how to clean that data, how to pre-process that data. We already see in yesterday's class. So today we have to see the data exploration. Okay. So we have to analyze the data sets. Okay. And we have to find the insights from that data patterns and potential issues which are facing inside that data. Okay, before applying the machine learning, this is known as data exploration. Like what we said, before building the machine learning model, the exploration data exploration helps in detect pattern, identifying the missing values and remove the outliers. Okay, we have to remove the outliers to improve the model accuracy. For that we use data exploration. What is outlier? Anyone have idea what is outliers? Like there is a data, okay, there is a data which is in between the 1 to 10 numbers, like 1 2 3 4 5 6 7 8 9 10, but the one number is get like 90 90 90. So this number is an outlier, okay, because it is an out of range undetermined data we got, unconditional data we got. That data is known as outlier. Okay, guys.
Okay, sir.
So the next one is data visualization. So first of all, the goals of the data exploration we have to see. The goals of data exploration is understand the structure of distribution of the data, identifying the missing values and outliers, find the relationship between the variables, detect the data imbalance, where is data is when we have to classify that data, we are facing some problem at the time of classification of data. That's all come under the data exploration. So next we have to see is descriptive. So we already see in pandas how to write the code for the data set. Okay. So means if you want to display first 5 rows, okay, these all checking the database structure we already see. Okay, guys, we already see in pandas module, like how to fetch the first 5 records, how to fetch the last 2 records. We already see this all into the pandas module. So for descriptive statistic, we use a df.describe function we use in that. And to identify the missing value, for that we use a df.is null function we use. For detecting outlier, there is a method. One method is there. Like outlier can be detected using visualization technique like box plot or statistical methods like the interquartile range we can take as. So identify the correlation between features. For that we have to use as Seaborn. Seaborn tool we have to use. Okay, we will see one by one this all. How to find the correlation in the data. Okay, so next what we have to see is data visualization. So data visualization is the process of representing data graphically using chart and plots. Okay, means the data which is present in Excel sheet. You all aware about the Excel sheets, guys? What is Excel? You know, guys, what is Excel sheet? Anyone have idea what is Excel sheet?
That is used to design any marks list, etc. Like 10th class marks list and inter marks list.
Okay,
Just
okay,
like
okay. Anyone?
Tells employee details in table forms.
Yes. Our attendance sheet. It is
Yes, sir.
also in
Excel.
Excel. Yes. Okay.
Yes, sir.
So these all the data which is coming like that. We have to analyze that data. Like no one understanding. Okay. Like now till now I'm taking the complete your attendance till now. Okay. But I want to tell to management team who is present till now. Okay. For that, for better understanding, I go for the data visualization. Okay. How to visualize that data by using chart, plots. Okay, understanding the trends, relationship and pattern, how many students are present, like Pushpa is coming daily, so at the Pushpa there is a bar graph on daily lecture, the highest length of bar graph we got into the Pushpa's data. Okay, this all come under the data visualization. If you want to if you want to present the if you want to present the insights of the data, so we go for the data visualization technique. So what is data visualization? Representing data graphical using chart and plots to understand trends, relationship and patterns. So what is the importance? What is the importance of data visualization? Makes the complex data easier to interpret, identify the trends, correlation and patterns, helps to detect anomalies and outliers. Okay, if there any outlier is present, so we detect by using the data visualization. Aids in decision making before applying to machine learning. We prevent any issue at the time of machine learning we are facing. We prevent that by using data visualization technique. So there are some common data visualization technique like univariate analysis, single variable, okay, and box plot is there for outlier detection, and there is a bar chart also for categorical data. What is categorical data? Anyone? Group, classes,
Alphabetical data.
yes,
numerical
alphabetical data.
Yes, sir.
Which data? There it goes. Categorical data is come under the group and categories, okay, like classes,
Yes, sir.
gender, color, city. Okay, we have to convert
Yes,
this
sir.
categorical data into numerical
Numerical
data
data.
by using encoding technique. Okay, so we use bar chart also for categorical data like that, and there is a bivariate analysis also, two variables. Then line plot is there, multivalued analysis is there, pair plot is there. Okay, that many examples are there for the best practice for data exploration and visualization. Choose the right chart. Okay, like if when we want to do the data visualization, what type of data is there? Like there is outlier is present, so we have to go with the different type of graphs. Like that, if there is outlier is present, and if wait a minute. So if their outlier is present, so then we go for the box plot. If there is a if there is a only numerical data, then we go with the bar 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 graph. Okay, histogram we can go with the histogram if there is a numerical is data present. Okay, according to the application, according to the data, we have to use the charts and plots. Okay, guys. So check we have to first of all we have to check the data quality, identify the missing value and outlier before building the models, use color effectively, Like there is a heat map and scattered plot with the color differentiation, improve readability. Okay, if you want to good readability, so use different types of color, interpret it before modeling, understand the data trends before applying the machine learning models. So the next what we have to see is we have to see the descriptive and inferential statistic. So first of all, we have to see the descriptive descriptive static. So descriptive static. So descriptive static summarize and describe the characteristic of a data set. It helps in understanding the main feature of the data through numerical and graphical representation. Okay. So in descriptive analysis, there are three types. Okay. Mean, median, mode. Anyone have idea on mean? Anyone have idea on mean?
In mathematical, it is used to average the sum of observations.
Wait a minute. This is last slide. Wait a minute. Ma'am, ma'am, you Wait a minute, guys. I am. Uh, where is that PPT? I'm missing. I missed that PPT. Here. Okay, so what is first of all we have to see the descriptive and inferential statistic. So in that first one is the descriptive statistic. Okay, so summarize and describe the characteristics of a data set using measures of central tendency, dispersions, and shape. Okay, so in the descriptive statistic there are three types. So first one is a measure of central tendency. Okay, so in measure of central tendency, no, wait a minute first. Yes, there are three types. So the first one is a measure of central tendency. So in that summarize the center of data. So in that there is a present mean, median, and mode. So what is mean? Anyone have idea what is mean, guys? What is mean, guys? Your voice is not clear.
Average, sir.
Yes, average. We can say as average. So for that, wait a minute. I will try for I want to told you in good way. So that's why. Wait a minute. My screen is visible, guys.
No, sir.
Now,
Yes, sir.
so see here the descriptive statistic. Okay, so there are three types of descriptive statistic. The first one is measure of central tendency. Second is the measure of dispersion. The third one is measure of shape. Okay, so the first one is in the measure of tendency. There are three types. The first one is mean. Okay, mean also known as an average. Okay, so this is the formula. So this is the formula of mean, like the sum of all the numbers, okay, with the total of the number of total numbers of count of number, okay. So like there are we take there are five, 1, 2, 3, 4, 5, up to five numbers are there, okay. So here we do the summation of that numbers like 1 plus 2 plus 3 plus 4 plus 5, okay. Then here we write how many numbers of data is there, 5, okay. So we divide this total sum with this count, okay, count of that element. So what it will give, it will give 5 15. How many it gives, 1 plus 2 plus 3 plus 4 plus 5, how much it will give?
15, sir. 3, sir.
Yes, so 15 divided by 5, how much it will
3.
give? 3. Yes,
3,
correct.
sir.
The average salary example, we can take average salary of employee in the company. We can find the average, okay, by using this. So in median, we find the middle values, okay. The number,
Yes.
the middle number when the data is sorted, okay. Like there is a 15 records. In 15 records, there is a like uh, we have to find the middle value. So which one is middle value? 7.5.
7.
So so there is like we have to take the 8 and 6, okay. Then we do 6 plus 8 divided by 2, okay. So 6 plus 8, how many? 14 divided by 2, how many got we got
7.
7. So 7 is the middle value. If there is an odd number, then we have to find the near number, okay. Like there is a 11, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then 11, there are 11 numbers, so which one is the middle number there?
5 plus 6. 8.
5.5, okay. So 5.5 is middle. So what we have to do, we want to take 5 5 plus 6 divided by 2, okay. So how many it will give?
5.5.
Yes,
5.
so like that. So what is mod? Most frequent value. There is a data. There is a 10 data. In that data, we got four time one we got, and then we got two, three times, and then five we got one time. Okay. So the most frequent number is one.
4.
Okay. So we got one for four times. Okay. So most frequent number is one. So next we have to see the measures of dispersion. So in that the range is there, variance is there, and standard deviation is there. So what is range? The difference between maximum and minimum values. We take the range. Okay. Like sometimes we say I think I got a mark nearby 50 to 60. We say like that, na. So this is called as range. Difference between the maximum and minimum number. So measure the spread of data around the mean. Okay, around the mean. We have to measure the spread of data around the mean. Okay, so we do the sum of x1. Like there are 3 4 data is present. Like take there are five data, five numerical data is there. One, 1, 2, 3, 4, 5. Okay, so here first of all here it goes 1, okay. Then we find the mean, okay. So already we find mean here, okay. So that mean value we have to put here. Then here we have to write the how many numbers are there. There are five numbers, okay. Then here we have to do the square root of this. Then we have to but here in the place of x of I, here we have to write 1, then second time we have to write 2, then plus 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 we have to do the values. Okay guys, that's like we have to find the variance. In standard deviation, we have, this is the square root of the variance. Okay, see, this is the standard variance and this is the square root of the variance.
Variance.
Okay, so what is wait a minute, skewness. Skewness means there are measures of shapes. So the measures of shape is skewness. So there are three types of skewness: right skewness, normal skewness, and left skewness. Okay. So wait a minute. In normal symmetrical distributed, okay, we said the normal the normal skewness we said as a normal distribution. Also there is a the skewness, the curve is created is the normal. Okay, in right skewness it is a asymmetrical distributed. Uh, the uh, the left tail is right tail is the most longer tail. Okay, in the right skewness, and in left skewness the left tail is very long. Okay, so like that. So kurtosis measures the weather data have heavy or light tails compared to a normal distribution. It is a little bit same like skewness only. So let's see the inferential statistic. So the the inferential statistic help us to make a conclusion about a pollution based on a sample. Inferential statistics help. Wait a minute, where is our PPT? Okay, so inferential statistic. So make a conclusion about the pollution, about the population. Inferential statistics help us to make a conclusion about the population based on a sample. It involves a probability theory to make a prediction or test a hypothesis. Okay, so in India, how much is population? Anyone have idea how much the population in India? Population of India. Anyone have idea? It is more than 1 to 5 crore. 125 crore. Okay, it is a more than 100 125 crores. Okay, so it is more than that. So we have to find the how many males and females are there in that. So we can go to single person. It is possible to go.
No,
No,
sir.
sir.
It is not
It's very
possible.
difficult.
So
It's very difficult to know.
yes, it is difficult and it is impossible. Okay, we can't able to go a single person and then we take a survey of that. It is not possible. So we take. So what we have to find how many males and females are there. Okay, so for that we go for the sample analysis. So what is meant by sample? From the big data set we collect some data. Okay, small data. This is known as sample. Okay, like there are 1,125 population is there. We take only 10K peoples. Okay, from different region. Understand, guys?
Yes, sir.
Yes, sir.
We take like there is an 125 population, 125 crores of population in India. So we take 10 hundred peoples. Okay, 10 hundred, not we take 10,000. Okay, we take 10,000 peoples. Okay, from different state or from different areas. Okay, then we analysis on that data. Okay, this is known as sampling. From the big data, we collect some sample with different region. All over India, we collect sample. Like from Jammu Kashmir, we collect 500 people. From Maharashtra, we collect like 300 people. From different states, like from Odisha, from Telangana, from AP, we collect people samples and we take survey on that. Okay, on 10k people. For 10k people, it is possible to take survey, guys.
Yes, sir.
Yes, it is possible for 10k people, like 10,000 people. It is possible to take survey on 10,000 people. So this is come under the sample. So inferential statistic help us to make conclusion about the population based on the sample. It involves the probability theory to make a prediction or test hypothesis. So so first one we have to see the hypothesis testing, determine if there is no enough evidence to support a claim. Okay, we go for the hypothesis testing if there is any possibility to find that data from 10k people. Okay, if we got any like insight from that data, then only we go for that. Okay, so there are also two types, null hypothesis and alternative hypothesis. So in null hypothesis there is no significant difference exists. Okay, there we didn't got any data which have difference in male and female. This come under the null hypothesis. And in alternate hypothesis there is a significant difference, okay, in the data. Like example, there is a A/B testing in marketing. Does a new ad campaign increase sales? Okay, so this is the one more example of that. So the next is confidence interval. So a range within a which we accept the true population parameter to lie. Okay, we give some range. Okay, like in your class there is some student are there which has an height of say 160 centimeter and 170 centimeter. We give one range. Okay, like in between 160 and 170 centimeter. So we are 95% confident that average height of the student is between 160 and 170 centimeter. So always we give the range. Okay, guys, we expect the range. We always give an range values. Okay.
Yes, sir. Okay,
So
sir.
what is p-value in inferential statistic? Probability of obtaining result as extreme as observed if the null hypothesis is true. Okay, we work on the null hypothesis at the end. If it is true, if the null hypothesis is true, then it's called as an p-value. Okay, so is if the p is less than 0.05, reject the null hypothesis. So what is regression analysis? So predict one variable based on another. Okay, we predict the one variable, okay, based on another variable. So like predicting house price based on the size. Like there is a 1 BHK house. So there is a 1 BHK house in Hyderabad. It's like 1 crore rupees. So same size of high house in that area. How many price? 10 crore. Okay. So this is come under the regression analysis. This is the example for regression analysis. So next one is the data distribution. So data distribution describe how data points are separated across the data set. Okay, describe how the data points are separated across the data sets including normal, skewed, uniform, binomial and Poisson distribution. So normal distribution is bell curve. Bell, you know the bell, you all know bell, this bell symbol, guys.
No, sir.
You know bell symbol. Wait a minute, I will show you the bell symbol. Yes, ma'am. Hello, guys.
Yes, sir.
Hello. So, what is bell curve? So, this is a bell curve. You
Yes,
know
sir.
now, this is a bell curve. Okay. This is in between the both parts are. This one is also same, and this one is also same. Okay. So, this is a bell. Bell symbol. You know, in temple there is a bell. Understand? Like bell
Yes,
in
sir.
temple is there is an bell. This is a bell curve. Okay, this is called an bell curve. Okay, this is a symmetric, complete symmetry. This side is also this part is also similar to this part. Okay, so this is known as bell curve. So this is come under the normal distribution. Most data point cluster around the mean. Okay, so this is the data and this is the mean. Okay, like here is take 1 and here is 2. 2, 3, 4, 5, 6, 7, 8, up to so many data are there. Okay, so here somewhere here we got an mean value. Take on 5 we got an mean value here. So this is the mean line. Okay, so here in bit nearby the mean we got some data. Okay, this is some data we got near the mean. The most data cluster point cluster around the mean. Okay, these are the cluster points around the mean. This is a mean line. So this is come under the normal distribution. Any doubt, guys? Guys, hello. This is a cluster point which are nearby the this range mean. Okay. So this is known as normal distribution. Guys, I'm audible.
Yes, sir.
Yes, sir.
Example, height of people. Okay, like in your class, there is a most people are like we find the average of the height, but there most more people are in between the nearby the average. Okay, so these all come under the normal distribution, bell curve. There is a skewed distribution. So there is a skewed distribution in that there are two types. The first one is right skewed, and second is left skewed. So the first one is in the right skewed is also known as positive skewed, and left also left known as an negative skewed. Okay, in this long tail on the right, okay, like this it will see. Okay, right skewed, right skewness. Okay, and in left skewness, how the data is going, this will be long. Understand, guys?
Yes, sir.
So the mean is
Yes,
going
sir.
coming here. Okay, and here the mean is coming here. So the data which is the point cluster points are here, and here also due to the outliers the data is going up to here. Okay, there outliers are present, unconditional data, unpredictable data is coming. Okay, so this is a right skewness and this is a left skewness, and normal skewness we already see normal distribution bell curved, like this bell curved. Okay, guys, this is normal distribution and this is the skewness, skewed distribution, skewed, what we said as T. Okay, skewed distribution. So next is uniform distribution. So all values have an equal probability of occurring. Okay, all value has an equal, like uniform distribution. We got an complete uniform data. So binomial distribution used in probability, like coin toss outcomes. You know already. I think you are aware of this binomial distribution. This is used in probability, coin toss outcomes, dice, uh, uh, what we said, throwing the dice, shuffling the random cards are there. Okay, guys, you have idea on this.
Yes, Yes, sir. sir.
So
Sir.
this is come under the binomial distribution. So let's see the visualization data distribution. Visualizing the data distribution. So in that in histogram, when we use histogram, shows the frequency of values in bins. Okay, so wait a minute. So we create one histogram, like sorry for my drawing, I will try my best. Just adjust, guys. Okay, I think you understand what I'm telling you. Guys, you have idea? Guys, you understand this? You able to understand?
Yes, sir.
So wait a minute, I will show you the wait a minute. I will show you the diagram. What is histogram? Wait. Uh, histogram. So this is the histogram. Okay. So this picture is of histogram. Okay. So histogram and so this is the histogram. This line. Okay. So this line is known as bins. अरे यार now it's okay. So this is the bins. This is known as bins. Okay, these bins, the lines top of this histogram is known as bins. These are called as bins. Okay, so show the frequency of values in bins. Okay, the data which is in between 0 to 10. Okay, it is nearby 50. Take a number of employee. Okay, so distribution of salary of the employee of ABC corporation, any corporation, any company is there. Okay, so the distribution, how many numbers of employee, 0, 100. So salary in thousands of dollar. So the employee which has 0 to $10,000 salary, it is a 50. Number of number of employees 50. Okay, it is in between the 0 and 100. Guys, are you understand what I am
Yes,
saying?
sir. Yes, sir.
So in between of 0 and 100, there is a 50 is present. Okay, so there is 50 is present in between this data. So the 50 employees have a salary from 0 to $10,000.
Dollars.
Okay, so this is the for range. For range purpose, we use histogram. And the employee, how many employees have a salary from 20 to 30, in range of 20 to 30, how many employees are there?
Two,
250.
200.
250.
Yes, 250. And how many employees have a salary in the range of 60 to $70,000?
250.
250.
Yes, correct. And how many employees have an salary of 90 to $100?
10 or 20.
Yes, yes, we can calculate as a 10 or 20. Okay, correct. So this is the histogram. Any doubt in histogram?
No.
Sir.
How, let's see the definition of histogram is a popular graphing tool. It is used to summarize discrete or continuous data. What is continuous data?
Numerical.
Yes, numerical data. Yes, that measure of on a interval scale. Okay, range in interval. Okay, in range. It is often used to illustrate the major feature of distribution of the data in a convenient form. It is useful when dealing with the large data set. Okay, so histogram device of the range of possible value in a data set using classes or a group. Okay, here we give the group of employees. Okay, number of employees which lies on the salaries. Okay,
Okay.
so so next we have to see the box plot. Now we have to see the box plot. See, this is the image of box plot. Okay, so here we give the range. Okay, interquartile range we are given. Okay, so here is the minimum value and here is maximum value. Wait a minute, guys. Uh, Wait a minute.
वो तो बच्चा आ जाए नेट पता है
Hello, guys.
Yes, sir. Yes, sir.
So wait a minute. Uh, See, this is the we use a box plot. This is called an box plot. Okay, this is the exam. This is the diagram of box plot. Okay, so box plot identifies the quartiles, median, and outliers. Okay, the which value is present here, like outside the max, is known as outlier. The which value is in the less than minimum, then it's come under the outlier. Okay, this understand to you,
Yes, sir.
guys? Guys, hello.
Yes, sir.
So which data is it not present in the in between the minimum and maximum? It is outside the minimum and maximum range. It is known as outliers.
outlier
Okay. So the minimum to Q1 we consider as a 25%. This line is known as whisker. Okay, and this line is also called as whisker. So from here, sorry, wait a minute. So this is the from mean to quartile, lower quartile, it's an 25% only. From Q1 to Q2, okay, this is the lower quartile, this is a median quartile, okay. So this is the median line, okay. We already calculate how to calculate median, we already see, okay. So this is come under the 25 from Q1 to Q2, okay, and this is the upper quartile from Q2 to Q3, it's a 25%, and this is the remaining from upper quartile to max value, it's a 25%, in which the data we got, okay, in this range, it is known as interquartile range, okay. So wait a minute. So interquartile is a statistical measure that represents the spread of the middle 50% of a data set. Okay, in that we got a 50% of data set. Okay, the remaining is here in on the whiskers. Okay, it is useful to detect the outlier and understanding the data distribution. It is helpful for the data distribution. So, is there is any formula for that? Yes, there is a formula like this. IQR is equal to Q3 minus Q1. Okay, guys. Q1 Q1 we known as first quartile or 25th percentile also. The median of the lower half. This is the lower half data. Okay, lower half data of the data set, and the Q3 is known as the third quartile or 75th percentile, the median of the upper half of the data set. And IQR, this interquartile range, the range between Q1 and Q3, covering the middle 50% of the data set. Okay, guys.
Yes, sir.
For calculating the IQR, first step is sort the data in ascending order, then find the Q1. Okay, we have to find the Q1 first. First quartile we have to find median of the first half of the data. Then we have to find the Q3 third quartile. Then we find the IQR. How to find IQR? IQR equals
Okay.
to Q3 minus Q1.
Q.
Okay, let's consider there is a data set like 257. Wait a minute, where we write on VS Code we write. Wait, so take there is a data set. There is a data set like take this data set as 257, 10, 15, 22, 25 we take, and 30. So this is the data set. So 257, 10, 15, take 18 also, take 18, 22, 25 and 30. How many numbers of data is there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 data. Okay, so how to find the Q1? Okay, so first of all we have to find the Q1. So first of all we have to find the Q1. We have to find this Q1. 25th percentile we have to find. Lower quartile we have to find. So what we have to write for this? Yeah. So how to find this one? So first of all we have to see the data which is in a lower half. Okay. So lower half data is 2, 5, 7 and 10. Okay. Then the median of data we have to find the first of all we have to arrange that data into the ascending order. We have to sort that data into the ascending order like 2, 5, 7. Okay, it is already in the ascending order. So there is a 9 data. So this data is coming under the Q1.
Lower quarter.
Okay, lower half, and this data is coming into the IQR. Okay, and the remaining data is come under the upper half
Upper.
from 18. This is the upper half and this is the lower half. Okay, so the data is already arranged in the ascending order. So what we have to do is here we have to write comment out Q1 equals to what we have to write. So we have to find the um, we have to find the median of this. So how to find the median? So here we write 5 plus 7, 5 plus 7 and it divide by 2. Okay, so how many it gives? Anyone have idea how much it will give?
6.
Yes, it gives 6. Okay, so we find the value of Q1. So what is the value of Q1? Q1 is 6. Okay, so value of Q1 is 6. So now we have to find the Q3. What is the formula for IQR?
Q3
Anyone?
minus Q1.
What is the formula for this complete IQR interquartile range? Q3
Q3
minus
Q1.
Q1.
Q3 minus Q3 minus Q1. Okay, guys.
Yes, sir.
What is the formula for IQR?
Q3
Q3
minus
minus
Q1.
Q1.
Yes, Q3 minus Q1. So let's first we have to calculate this one also. So Q3 we have to find now Q3 for finding the IQR. So here we write Q3. So here we write Q3, and what is the data of Q3? First of all, here we write 2, comma 5, comma 7, comma 10. This data is come under the Q1, and in Q3 it's coming 18 and 22, 25 and 30. Okay, this data is coming under the upper half. Okay, so what we have to do is, first of all we have to do the 20, we have to find the middle. So here we write 22 plus 25. How much it will give if we divide by 2?
23.
How much it will give, guys?
23.5.
Yes, 23.5 it will give. Okay, so it will give 23.5. So now what we have to do is, we have to find the IQR. IQR is equals to Q3 minus Q1. So how much it will give? Q3 minus Q1, 23.5 minus how much? 6.
6.
How much it will give?
16.5.
Huh? How much it will give? It will give 17.5.
7.
Okay, so like this we have to find the IQR, the range. Okay, so how to find the outliers? Detecting the outlier using IQR. IQR are values that falls outside the following range. Okay, so above this range, it's found above this range. Okay, like there is a number which is what we take 90 we got. Okay, this is complete out of range. Or the number which we got minus 11. These are the outliers in the data. So this is the example for box plot. Okay, so how to find the outliers, how to detect the Q1, what we have to write for finding the outliers for lower bound. This is lower bound. Okay, the data which is uh, below the minimum, and which is the data after the max. This is known, the data which is below the minimum is known as lower bound, and which is data which is present after maximum value. Okay, then it's known as upper bound. So in lower bound, how to write lower bound? Q1. Okay, we already find Q1, guys. We already find
Yes, sir.
1.5
Sir.
into IQR. Okay, like that we find lower bound. For upper bound, how to find upper bound? Here we have to write upper bound and here we have to write Q3. Like that we find the upper bound also. So like that we can find. So this is the for box plot. So where we are. My screen is visible now, guys.
Yes, sir.
So what we saw now, data distribution, we see up to box plot. Okay, correlation and covariance we will see tomorrow. Okay,